Hello, future scientists. Welcome back to another tutorial, this one for grade 12 chemistry. Specifically, we're going to look at how to propose a reaction mechanism. Lots of students have trouble with this because there's so many different possible mechanisms you could propose. But in this tutorial, I'm going to go over the easiest way to propose a mechanism, and we'll do a couple of examples together, and I'll give you a sum to try on your own. Let's get started. So for each example, what we're going to do is, one, we're going to look at the rate law and say the order of the overall reaction, and then we're going to propose a mechanism. Now the order is simple. You just look at the rate law, take the exponents of your concentrations and add them. So this is 1 and 1, so this is 1 plus 1 gives you a second order reaction. All right, now how are we going to propose a mechanism? Now, if you look at our first example, what I'm going to tell us to do for the first step is to always follow the rate law. But in this case, you'll notice that our reaction follows the rate law. So what does this mean? This means this is an elementary process and you don't actually need to write or propose a mechanism. So how do I know it follows the rate law? Well, you have ammonia to the power of 1. So we have our 1 coefficient in front of ammonia. We have hydrogen chloride to the power of 1. We have our 1 coefficient there. So it matches the rate law. No mechanism is necessary. Well, let's look at another example where we do need a mechanism. So in our second example, we have the decomposition of hydrogen peroxide. Now our rate just shows hydrogen peroxide, or the square brackets mean concentration. So the concentration of hydrogen peroxide to the power of 1. But notice our coefficient is at 2, so this is not an elementary process. We need to propose a mechanism. So step 1, follow the rate law. So what do I mean by that? Take the rate law, so H2O2, and use the exponent as your coefficient, so 1. Next, try to break that apart to make one or as many of your products as possible. So if I just remove an oxygen, I can have H2O, right? So that's one of our products. And then write what you have left over. So we still have an O. Now it's okay if you just leave it like this. It doesn't have to follow Hofbrinkel, or it doesn't have to be a diatomic molecule, because this is just an intermediate step. We broke apart that bond, and now that oxygen is going to come over here in step 2 and bond with something else. So anything that is not one of your products, like this oxygen, we are going to reuse in step 2. And then add any of our reactants that we didn't use in step 1. So we only used 1 molecule of hydrogen peroxide, but our equation has 2. So let's add another one. So H2O2. And then write your remaining products. So I've already have 1 H2O, so I need another one. So H2O, and we need an O2. And you'll notice it works out perfectly, right? Because if we take 1 oxygen over here, you've got H2O plus O2. There's your mechanism. Now the step that follows your rate law, that's your slow step. And your second one is your fast step. That's all there is to it. You want to try another one? Let's try one more. All right, so in this example, we have 3 moles of oxygen becoming 2 moles of ozone. And the rate law is oxygen, the concentration of oxygen, squared. So that does not match our reactions. This is not an elementary process. It's of order 2. And we need to propose a mechanism. So just like I did in the first example, start with the rate law. So the rate law is O2 with the coefficient of 2 in front. So 2O2. Then try to make as many of the products as you can. So this is a total of 4 oxygens. I can only make 1 ozone. So O3. And then write what you have left over, plus O. Okay? If you really want to write it as O2, that's fine. You just need a 1/2, a fractional coefficient, but it's not necessary. So we're going to take this oxygen now and use it in step 2. Okay, so remember, any of our products that is not one of the products we want, we're going to reuse in the next step, and we're going to combine it with any reactant we haven't used yet. So we've used 2 oxygens. We will need to use a total of 3, so let's use 1 more. And then that'll give us the remaining products that we're looking for. So 1 more ozone. So we created 1 here and 1 there. This followed the rate law. So this is our slow step. And every other step is fast. Fairly easy? All right, well, here's 2 examples you can try on your own. Let me know in the comments what your proposed mechanisms are. And I want 2-step mechanisms, right? Use this easy method that I've shown you. And if you want any other resources for high school STEM courses, you can check out my channel, my website, or some resources for free are available for you in the description. Thanks for watching, and I'll see you in the next tutorial.